trig laws. We've called it trig laws because we're not sure which ones we're going to use yet. You have the options of your sine law and cosine law. And we're going to decide which of these two major ones to do. Technically, there's a tangent law, but you don't need to know it because between these two, you can solve everything. Okay, so there's no purpose of finding that third one. They've given us a triangle. So the actual most difficult part to this was probably going to be...
You can use sine law, can't you? Really?
Yeah, you're probably right. Yeah, just by looking at it. But setting up the triangle will be really helpful too. We don't know if it's right angle or not, so we're going to say it's not to scale, but we're just going to draw it out. Labeling a triangle will help a lot, especially when it comes to cosine law. So, they've given us at least two. They said there's a side x and an angle x. So, normally actually the angle is the capital letter. So we'll call that the angle, and we'll call this side. And then they said f as another one. So we'll call this side f, and this is capital F. Okay, and we'll just, these two are the angles here, we'll say. Other letter, we could give it another one, but this is all the info they've given us. So we'll go from here. We're going to label them. X is 82.2 centimeters. And side F is 89.3 centimeters. That's awesome. And internal angles, angle X is 67 degrees. And this is what we're looking for. We can call it X. We'll call it theta because X will get confusing because we've already used the letter X in here. The question becomes which tool to use, sine law or cosine law. You can memorize specific parts of triangles and go, oh, this one, if you have these three sides and this angle. My suggestion is, as long as you know the two laws, usually sine law is easier to work with. Start with sine law. And if you don't have enough information, by deduction, you have to use cosine law to solve it. So just so that you recall, your sine law looks like this. You usually have three ratios. Sine A over sine B over B is equal to, I'll move over just a little, sine C over C. And you can put that vice versa. It doesn't really matter. You can flip those fractions around. In our case, let's just relabel sine. We don't have an A side. We have an X side. So we're going to say sine angle X. Whoops. Yeah, that's right. Sorry, capital. Side X. We have a sine F. Side F. And we have some unknown. Well, lucky for us, we don't really need a third side. We only need two sides for the sine law. So let's go about plugging these in here. I'll get a little highlighter. My side F is down here. My angle F is my theta. It's the unknown, so that's what we're going to solve for. My angle X is 67, and my side X is 82.2, which is down here. So we're just going to use some substitution and plug those in. Sine 67 over 82.2 is equal to sine, we're going to say theta, or we can leave it as F. Do you care?
No.
Okay, let's leave it as F. I called it theta, but there's really no point to it. 89.3. Well, now I'm just working with equivalent fractions. This becomes just a matter of algebra now. I want to isolate, what color did I call it? Green? Okay. I want to isolate for F. So I'll show you the most efficient way algebraically to do this. Many students will cross multiply. That's going to add an extra step. My goal is to get F by itself. So I'm just going to move the denominator over, which essentially means I'm going to multiply both sides by 89.3, which creates a one factor on this side, and we're going to multiply by 89.3 over here. When we do that, I'm not going to carry this out yet. I'm going to go 89.3 times sine 67 all over 82.2 is equal to sine F. Remember, F's what we're trying to solve. Well, F's not quite by itself. It's technically in a function right now. It's in that sine function. So I want to use the inverse of that function, or sine inverse. So that we get just F. And when that comes over to this side, it will look like this. It will look like sine. Looks like it's the power of negative 1. But that's technically the inverse of sine. And then these are the arguments to it. 89.3 times sine 67 divided by 82.2. Okay, now this is just a matter of using my calculator. Assuming my teacher doesn't want me to know the series for sine. So I'm going to jump over here and I'm going to punch it in. this function, sine inverse. It has division to it, and it was 89.3 multiplied by sine 67, whoops, all divided by 82.2. Look at this.
You forgot a bracket with the 67.
Oh, it doesn't like it. It says it's undefined. Sine 67, my radians. This might be right. It may be that we've made what's called an impossible triangle. This original question may be impossible. So I'm going to do a little bit of digging before I go about doing this. I'm going to jump back. We're going to talk about a property of sine. Let's see. Maybe the teacher specifically did this on purpose. I'm going to jump back to this piece here. It's the second step here. Sine f. And I'm going to add a little more information. We know sine f is actually equal to the opposite over the hypotenuse. Okay? If this was a 90-degree angle triangle. That also tells us something about sine. If I were to draw out sine, and it's a right angle triangle, and this is my angle, I got to go the opposite over the hypotenuse. Well, there's a relationship between the opposite and hypotenuse. And that relationship is that the hypotenuse is always greater than the opposite. Now, because this is a fraction, what that means is the bigger number is always on the bottom and the smaller number is on top, which means we always get some number that is less than 1. I mean, technically you could have them the same length, but it's no longer a triangle. So we always get a number that's less than 1. In order to create a number less than 1, our numerator must be less than our denominator. So let's actually do a little math here. I'm actually going to just carry out this piece. And this will tell me if this ends up being a number bigger than 82.2, then this is an impossible triangle. And maybe that's what your teacher meant by when they wrote if possible in this question. So let's go back to our calculator. I'm just going to focus on the 89.3 times sine 67. Oh, look at that. We get a number 82.201. I feel like this is very specifically chosen by your teacher. 82.2, oh my gosh, 01 is greater than our denominator, which is 82.2, just by like 10th, 100th, 1000th. By 1/1000th is larger, which means this triangle is impossible. This is not a real triangle. Should I spell that right? They've probably purposely done this. This is not a real triangle. Can't exist in our laws of our universe. So we did a lot of work, which is great. And if it was a triangle that we could solve, we would have been able to punch this in and it would have given us a value. But after some inspection, we realized whoever drew this triangle drew an impossible triangle. Now, there is a way I can make it a real triangle. If I increase this side length, is that right? Yeah. If I increase this 89.3 to something like 90, this would then work. I could then have a number, and watch, we'll do it on our calculator just to check. 89.3. I'm going to go back. I'm going to copy this. Okay, put it in there. I'm going to change this too. Oh, is 90 still too small? 100. Oh, 10. Oh, because the other one's different. It's the value. Sorry, I said it wrong. It's too large. If we go down, there we go. If we go down in size, it ends up working out. Okay. So they purposely created this triangle so for you to learn about the idea of some things are actually not possible. We can't just plug numbers into a triangle. It won't technically always work.